Hello students, Jai Hind. How are you all? I hope you all must be staying fit and keeping high spirits, isn't it? So today, during this lecture or rather during this session, we'll be discussing a very important and interesting arrangement which is known as slide wire bridge. Slide wire bridge. It is, students, also known as a meter bridge, because it consists of 1 meter length of standard resistance wire. So that is the reason why slide wire bridge is also known as a meter bridge, right? And it's a simple arrangement, and while performing this experiment, you need to have resistance box, then you need to have one-way key, source of EMF, galvanometer, and unknown resistance wire, obviously. And here I must mention a resistance box. From there, whatever key you are using, that value of resistance is introduced in the circuit. So by using resistance box, the value of resistance to be used in the circuit is known to us, right? And it will be given any standard resistance wire whose resistance is to be determined, right? And its specific resistance or resistivity can also be determined by using this particular apparatus. So basically, and then we'll make use of galvanometer as well. It's a very sensitive device which is used to detect the current. When it is put in a circuit, it either gives deflection towards right or towards left, depending on the direction of the flow of current. And in case no current flows through the galvanometer, then it will show zero deflection, right? So that's the use of galvanometer. And obviously, before we start with the theoretical part, the principle on which it is based, how to calculate the value of resistance of the given wire, I would like to watch a short clipping which will give you a feel of the apparatus, or it will give you a feel of the arrangement which we'll be using. So students, nice, do watch this short clipping, and I would recommend after watching the clipping, do watch the entire video so as to understand this topic completely. A slide wire bridge is also known as meter bridge. It is constructed on the principle of balanced Wheatstone bridge. It consists of a wooden board over which constant wire AB of 1 meter in length is stressed between the two copper strips. A meter scale is also fitted on the wooden board parallel to the length of the wire. Another central copper strip is fitted on the wooden board to provide two gaps across which a resistance box R and the unknown resistance X are connected. This instrument is used to measure an unknown resistance wire. This is the actual meter bridge, and one of its extreme end is connected to the positive terminal of the battery eliminator, while the negative terminal of the battery eliminator is connected towards the other extreme of the meter bridge, which is considered to be point C. There are two gaps, one on the left hand side and the other on the right hand side. A resistance box is connected in the gap which is on the left hand side of the meter bridge, while on the gap which is on the right hand side, the unknown resistance wire is connected. One terminal of the galvanometer is connected to the terminal between the two gaps, while the other end is connected to the jockey. So that makes the circuit complete. So students, after watching the clipping, I am sure you have understood the actual circuit diagram. Let me repeat the circuit diagram again, right? As we are aware, meter bridge is an instrument which can be used to measure the unknown resistance. It can be used to determine the specific resistance or the resistivity of a given wire, and it is based on the principle of balanced Wheatstone bridge. This is, students, a Wheatstone bridge which consists of 4 resistances connected in the form of a bridge. In this case, if the points B and D are at the same potential, then no current flows through the branch BD. In such a case, the galvanometer shows zero deflection, and that is when the bridge is said to be balanced. And we have mathematically verified that in the balanced condition, P by Q would be always equal to R by X. So it is on this principle that the working of meter bridge is based upon. Right, students? So construction we are already aware of, right? Just now we have seen the clipping. So it consists of a wooden board comprising of a scale 1 meter length. It also consists of 1 meter standard resistance wire, which is made up of constantan, manganese or eureka. Why we make use of this material for resistance wire? It is because for such alloys, the resistivity value is very high and also it has got low value of temperature coefficient. So basically the value of resistance of such wires won't change even with the change in the external conditions like temperature. So it must have low value of temperature coefficient, right? So these are the two properties which a standard resistance wire must possess. So here we make use of 1 meter length of standard resistance wire. So that is the reason why, students, slide wire bridge, it is known as slide wire bridge, it is also known as meter bridge because it consists of 1 meter length of standard resistance wire. And these are the metallic strips and they are the flat strips, they are flat because resistance offered by a conductor is inversely proportional to the area. So greater the area, the lesser will be the resistance offered. So using this flat metallic strips will reduce the resistance considerably. So the resistance offered by these flat metallic strips can be neglected. Right, students? And these are the two gaps, one on the left hand side and the other on the right hand side. Right? Now let's complete the circuit diagram now. Students, only one thing is to be noted down. It is based on the principle of Wheatstone bridge. So here let's locate the point. This terminal, it should be point A. This one, it should be point C. And the central terminal between the two gaps, it can be considered to be point D. Suppose this is point D, or rather consider it to be point B. Right? Consider it to be point B. Okay. A, B, C. This is point A, point B, point C. Point 2 I will tell you how to locate the point B. Okay. Now, the source and a one-way key is connected between the points A and C. Just complete the circuit diagram by taking the reference of that particular diagram, right? So between the points A and C, a source and one-way key is connected. Between the points A and C, source, this is a source, and one-way key, it is connected. Right? It's done. This end will be at higher potential, while point C will be at lower potential. Now look, between points A and B, known resistance, that is a resistance box, can be connected. This is A and B. Between these two, a resistance box is to be connected. From where the known value of resistance can be introduced in the circuit. This is the resistance box. Suppose we introduce resistance R from this resistance box, right? So R is between the points A and B. Then between the points B and C, this is point B, this is point C. So between the points B and C, we need to introduce the wire whose resistance is to be determined. Right? This is the wire whose resistance is to be determined. This is X. Its resistance is to be determined. This is the wire. Now here, remember students, the effective length of this wire would be between these two terminals. This is the effective length of the wire. Only between these two terminals. The extra length is to be avoided. You are supposed to consider only that length of the wire through which the current will flow. Isn't it? So current will flow along this direction, like this. Not through these additional parts. So you are supposed to neglect it. So while measuring the length of the given wire whose resistance is to be found, ensure the length of the wire to be measured between these two terminals. These two terminals. This is to be avoided. Right, students? So unknown resistance is connected between points B and C. Right? Now galvanometer. It's a sensitive device which is used to detect the current. It don't measure current. It simply gives diffraction either towards right or towards left, indicating the presence of current. If it shows zero deflection, it means that no current is flowing through that particular branch, right? So point B and point D. This is point B. So a galvanometer is to be connected. one end of the galvanometer is connected to the terminal B, like this. One end of the terminal is connected to point B, and the other end is connected to a jockey. And the other end is connected to a jockey. Now, that jockey is slided over this constant wire of 1 meter length. At a particular point, you will observe that the galvanometer will show zero deflection. So that is the balancing length, and this point would be the balancing point. This is the jockey. And this point, suppose it is the balancing length, and this is point D. Right, students? So now again, let's compare these two circuits. Both are identical, right? Just remember that simple circuit diagram of balanced Wheatstone bridge, and you'll be easily able to make this circuit diagram without any error, right? So, source and one-way key are connected between the points A and C. Source and one-way key are connected between the points A and C, right? Resistance box of known value, it is to be connected between the points A and B. And X, which is the unknown resistance whose value is to be determined, is to be connected between B and C. It is to be connected on the right hand cap, right? Galvanometer, one end is connected to point B, the other end is connected to point D. Over here, this end is connected to point B, while this end is connected to jockey. And this will be pointing at the balancing point. So D is the balancing point. Right, students? Here, I must mention, on keeping the jockey at the two extreme ends, the galvanometer must show deflection in the opposite direction. If it happens that at the two extreme ends the galvanometer shows the same deflection, then there must be some error in the connections. So please ensure that the connections are tight and the circuit diagram is correct. So how to check it? On placing the jockey at the two extreme ends, the galvanometer must show deflection in the opposite direction. So that's the way to check whether the circuit is correct or not, whether everything is correct or not, right? Then what you are supposed to do is take out a required value of resistance, any known value of resistance, and then slide the wire, keeping it vertical on the standard resistance wire. Just try to slide it. Then what happens is the needle will swing from one end to the other end. At a particular point where it shows zero deflection, that would be point D. And students, here I must again mention, the working of this meter bridge is based on the balancing method, isn't it? It is based on Wheatstone bridge. P by Q equals to R by X when the bridge is balanced. So, ratio is involved. So, it is preferable to obtain the balancing point between 35 cm to 65 cm. I repeat, choose that value of capital R so that the balancing point is obtained between 35 cm to 65 cm. That would be the most preferable region, right? Suppose this is the balancing point and suppose this is L centimeter. So, AD portion, this portion which is the length L of the standard resistance wire offers resistance P. While the other portion, it is of 100 centimeter length, so if this portion is of L centimeter, the rest of the portion will be of length 100 minus L centimeter. So this portion of the standard resistance wire will offer resistance Q. It will offer resistance Q. So now the circuit is complete, right? So experimentally we can easily determine the value of L. And as we have discussed, in the balanced condition, P by Q is equal to R by X. Balanced condition means when galvanometer shows zero deflection. This is when the bridge is said to be balanced, right? And as we are aware, this standard resistance wire is of uniform cross-sectional area. So students, resistance offered by the wire would be directly proportional to its length. Therefore, this portion is offering resistance P. So P would be directly proportional to the length of this portion. While this portion of the wire is offering resistance Q. So Q would be proportional to 100 minus L. Isn't it? So taking the ratio, what you get is P by Q is equal to L divided by 100 minus L. Put this as equation 1 and this as equation 2. So from these two equations, from 1 and 2, what you get is R by X is equal to L divided by 100 minus L. X is to be found. So it will be equal to 100 minus L divided by L multiplied by R. So this is the working formula. Clear, students? So R is known to us. L can be experimentally determined, which is the balancing point when the calculator shows zero deflection, isn't it? In such a case, the value of X can be easily determined. So while doing experiments, we normally do 3-4 observations. We normally take 3-4 observations, right? So take the value of R as 10 ohm, R as, in the next observation take R as 12 ohm, in the next observation take R as 15 ohm. So accordingly, changing the value of capital R, the balancing length will also get changed. But the value of X is found to be more or less same. So how to get the true value then? It will be obtained by getting by finding the arithmetic mean or the average of all the observed values of X, right? That is closest to the true value of X. So that is how this unknown value of resistance of this wire given can be easily found by using this arrangement known as meter bridge or slide wire bridge. Now students, once you are able to obtain the value of this unknown resistance, thereafter by using screw gauge you can easily determine its diameter. By using a half meter scale you can easily find out the length of this wire, and I told you it's not between end to end, it's between terminal to terminal. Effective length is between the two terminals, right? So length and diameter, it can be sorted out by using a centimeter, half meter scale and screw gauge. And thereafter we are aware, if its resistivity is rho, then we are aware of the formula. Resistance is equal to rho L by A. So it will be further written as rho L by cross-sectional area of the wire. It's pi r square. R is half of the diameter, so it can be written as pi d square by 4. So what about specific resistivity? So rho, it will be equal to x pi d square divided by 4L. So this is, students, the formula for the specific resistance or the resistivity of this given wire. So knowing the value of X, knowing the value of diameter of the wire using screw gauge and measuring the length of the given wire and substituting its value, you can easily determine the resistivity of the given wire. So we have done two things. First, the resistance of the given wire can be easily found. Second, the resistivity of that given wire can also be found, right? There are some other applications or uses of meter bridge as well. Students, this arrangement can also be used to verify the law of series combination of resistances. And the same instrument or arrangement can also be used to verify the law of parallel combination of resistances as well. So let's discuss those two topics as well. So first and foremost, we will try to verify the law of series combination of resistances. Law of series combination of resistances. So what we'll do is, two resistors will be given of unknown value, and we are supposed to verify the law of series grouping. So what does this law states? According to the law of series grouping of resistances, it states that the net equivalent resistance in the series grouping of resistances is given by sum of the resistances of the individual resistors. So this can be easily verified. So how to proceed like? So what to do is, suppose these are the two resistors which are given. This is R1 and this is R2. These two are given, right? Let us consider this to be 6 ohm and this is to be 3 ohm. Suppose these are known values. You can make use of resistance box, individual resistance box, or these are the resistances whose values are known and it will be given to you, right? Now what to do is, the series combination of R1 and R2 are to be put in the gap on the right hand side of the meter bridge. And series means they are to be connected like this, end-to-end connection like this. This is R1, this is R2. They are to be connected like this. So, it will be like this. These are the 2 points. So, these are the 2 resistors R1, R2 connected in series. This is R1, this is R2. Now, the same method will be followed. On placing the jockey at the 2 extreme ends, the galvanometer must show deflection in the opposite direction. Then only the circuit will be perfect. And thereafter, what needs to be done is take out any key from the resistance box. So, whatever resistance is being put in the circuit, it will be known to us. This resistance, R would be known to us. And thereafter, slide the jockey. Right? Slide the jockey over that standard resistance wire. And try to obtain the balancing point between 35 cm to 65 cm. So at a particular point, what happens is the galvanometer will show zero deflection. So the value of this entire grouping, the net resistance which is put in the gap on the right hand side, can be easily determined. Suppose the result obtained is, let us consider the result obtained is found to be 9 ohm. Right? And on adding these two, by applying this law directly, we will get Rs is equal to 6 plus 3, that will be 9 ohm. So, this formula will give you 9 ohm, and experimentally when you make use of meter bridge, then also the value should be more or less equal to 9 ohm. So, both will be in close agreement with each other. So, that will verify the law of series grouping of resistances. Clear, students? Again I repeat, the series grouping of R1 and R2 is to be kept in the right hand gap of the meter bridge, and then you need to proceed in the similar fashion. So obtaining the balancing length, you should easily get the value of R net. This is R net. So here what we will get is P by Q, it would be equal to R divided by R net. P is proportional to L and Q is proportional to 100 minus L, right? So, taking ratio, that proportion sign will get eliminated. So, R net, it will be equal to R into 100 minus L divided by L. This is what I have told you. This R is known to us. The balancing length can be easily obtained experimentally. Knowing the value of capital R and L, substitute this value and you will get R net. And it should be more or less equal to 9 ohm. In case it is of individual value of 3 and 9 and 6 and 3. So that makes 9 by using the law of series combination resistances. So you can tally both the values experimentally as well as mathematically using the law of series grouping. So that will validate this particular law. Correct, students? Similarly, you can easily verify the law of parallel grouping of resistances as well. Parallel grouping of resistances. So in this case, again, the same method or same steps are to be followed. Only difference is that in this case, the two resistors are to be connected across in parallel like this. This is R1 and this is R2, and these two combinations are to be connected over here, right? So suppose this is the first resistor connected over here. This is suppose R1 and this will be R2. Clear, students? In this case, find out the net effective resistance of the parallel grouping of R1 R2. Again, by same method, balancing method, P by Q would be equal to R by R parallel. So experimentally you can easily find out the result of these two. In case individual values are 6 and 3, R parallel would be roughly equal to 2 ohm. You can check it. So by using the law, what we will get? 1 by R parallel would be equal to 1 by R1 plus 1 by R2. It will be equal to 1 by 6 plus 1 by 3. So R parallel would be 6 into 3 divided by 6 plus 3. So 18 by 9, it will be 2 ohm. So while while performing the experiment, the result obtained would be more or less equal to 2 ohm in this case, which will be in agreement with the mathematical obtained value using parallel law of combination of resistances. So students, method is same, right? So again I repeat, a meter bridge is an arrangement which can be used to determine the value of unknown resistance or to determine the value of resistance of a given wire. It can be used to find out the resistivity of that given wire. Third, it can be used to verify the law of series grouping of resistances. Fourth, it can also be used to verify the law of parallel grouping of resistances. Right? So this is a very, very important topic both from your examination point of view as well as it's in your practical syllabus. So students, do practice this experiment, and when you will be performing it individually, then you will learn it and you will be able to retain it throughout your life. So learning by doing, that should be the motto actually. So be very, very careful while doing this particular experiment and do follow all the precautions, right? So all the best students. I hope you have understood this particular topic, and keep well, study well, and we'll continue in the next lecture then. Take care. Bye-bye.